Hello everyone, welcome to a video tutorial learning about geometric sequences. This is actually the first video in a series about exponential functions, but we're going to start off with geometric sequences because it actually is going to help us lead us into understanding exponential functions that much better. So here we go. We've got arithmetic sequences on the left. If you've watched my previous videos, we learned a lot about arithmetic sequences earlier when we were dealing with linear functions. And then we got geometric sequences on the right. My plan is to take some stuff we've seen before, look at some patterns, some sequences, and compare it to geometric sequences just to highlight the differences, but also some of the similarities. All right, let's start off with a good arithmetic sequence. First value is going to be 3. Next value is going to be 6, then 9, 12, 15, and 18. And the pattern goes on. And 3 would be my first term. 6 would be my second term of the sequence. A3, A4, A5, and A6. I'm just using some of the notation with geometric sequence. So let's take a look about what pattern is happening in this sequence here. So the first term, the starting value, is 3. So starting value, I'm going to write that out. Our arithmetic sequence is starting at 3. Now what do I do from that value? Well, the pattern is we add 3 over and over again. It's not too tough to figure out, right? 3 plus 3 equals 6. 6 plus 3 equals 9. 9 plus 3 equals 12. 12 plus 3 equals 15. And 15 plus 3 equals 18. And we could go on and on and on. We give a special name to that plus 3, that thing that we're repeatedly adding over and over again. And that's called our constant difference. So in this arithmetic sequence, the starting value is 3 and the constant difference is 3. We're repeatedly adding 3 over and over again. All right, so how do we do with that? If you remember, the whole idea about arithmetic sequences and constantly adding the same thing led us into working with linear equations. Remember, the big idea of linear equations is this idea of slope. Anything linear is constantly adding the same thing or growing at a constant rate. And so slope is almost the same thing as constant difference. But there we go. So arithmetic sequences had a constant growth pattern, and we saw that. Let's take a look now and compare that with a geometric sequence. So here's a geometric sequence for us to look at. We're going to start with 3, 6, 12, 24, 48, 96, and it goes on and on and on. And again, 3 is my first term. 6 is my second term, third term, fourth term, fifth term, sixth term, and so on. All right, so here we've got a geometric sequence. You've probably already seen here the pattern to get from one term to the next is not an addition pattern, it's a multiplication pattern. I'm multiplying by 2. 3 times 2 gives me 6. 6 times 2 gives me 12. 12 times 2 gives me 24. 24 times 2 gives me 48. 48 times 2 gives me 96. And the pattern is that we're multiplying, repeatedly multiplying every time. So in arithmetic sequences, the pattern is to add. I'll circle that. In geometric sequences, the pattern, because in algebra we're very, very interested in patterns, the pattern is to multiply. If you remember anything from this video, that's the big one. Geometric sequences means we multiply by a constant. Arithmetic sequences means we add by a constant. But let's use some terminology here. Geometric sequences, we still have a starting value. So we're still interested in what that first term is. We've got to start somewhere. In this case, it's still 3. But we call this number that we repeatedly multiply, it's called the common ratio. Which you may kind of wonder, why not the common multiplier, right? Well, the common ratio is 2. And you have to think of it in terms of comparing numbers. We call this the constant difference because if I took any two terms, 18 minus 15, the difference between any two terms gave me the pattern there, adding 3. The common ratio implies the same thing. If I take any two terms and I divide them, 96 divided by 48, that's a ratio. 96 divided by 48 is going to give me the value of 2. And so I can figure out what I'm multiplying by taking two terms, any two terms, consecutive terms. If I divide them, I'm going to get the pattern of multiply by 2. All right, so we call it the common ratio because if I take the ratio of any two terms, it's going to give me what that number is that I'm multiplying by. And what we're going to find is geometric sequences and the pattern of multiplying is the very heart of understanding exponential functions. So in this series, we're going to be working more with geometric sequences. We're going to be doing a lot with graphs, with tables, with a formula, and that's going to develop our understanding of exponential functions. And then we're just going to look at patterns, equations, graphs, applying exponential functions, doing all sorts of stuff with understanding, well, how does this pattern of multiplying repeatedly work? All right, hopefully this was a good introduction video. I'm excited to see what we have on the rest of the series here.